Okay, and last but certainly not least, let's try out a regression. And I know I've mostly talked about regressions as having more than two variables, but as you noticed, we're just getting started, so let's try one with just two variables first. And one way of thinking about a regression is that it's similar to a correlation, especially when there's like three variables involved. It's kind of looking at the relationships and associations between all three of them. But it is looking at a prediction or trying to fit a line on a graph. So we are going to click on Analyze. And look at that. There's a little submenu that says Regression. We're going to do a linear regression. And I've preloaded this. So let's look at if femmes or feminine people who are trans are reporting that they're getting enough social support. So we are going to go to Statistics. We'll include the estimates and the model fit for now. Oftentimes, you'll also want to look at the confidence intervals, but I will talk about that later. I've already pasted the syntax, and so now I'm just going to click OK, and it'll go ahead and run it for us. So with a regression, you'll notice you get multiple tables, and this can look overwhelming at first, but I'm going to explain what each of them means. So this is just telling you what variable you ran. That's all. It's saying I looked at femmes. And then the model summary, the biggest thing here right now is the R value, because what this R value tells us is the percent of variation that this model, the regression model, explains in our data. So this R value is 0.036. We will convert that to a percentage, which is 3.6%. So 3.6% of the variation in the dependent variable is explained by this regression that we ran, 3.6%. So depending on what kind of variables and data you're working with, that might not be a lot of the variation explained, or it might be. And then the ANOVA table, again, is just telling us if the averages in these two groups are different from one another. And so we look at the significance value here on the right. This is the p-value. It is less than 0.05. So the averages between these two groups are different from one another. And here, the coefficients table is the actual results of our analysis. And I will put a slide in with this table prettied up and explaining what each piece means. The significance level, you can see we did reach significance, so this is statistically significant. And you can see here that being femme, the folks that I identified as femme in my sample were less likely to report often or always getting the social and emotional support that they need. So here 1 equals, I think, not often or never, and 5 equals always. So femmes in my sample, regardless of gender, not taking gender into account, but specifically gender expression or presentation, femmes were less likely to be getting the social and emotional support that we need. Let me know if this is helpful, if this makes sense. Again, I will put a table that's like an annotated table in the next slide here. Oh, and I almost forgot to show y'all the syntax. This here is what the regression syntax looks like. So it's saying what we do with the missing data, what statistics we're running, excuse me, what p-values we want, and then what the dependent variable is, and what the independent variable is. And by saving this syntax, now I can rerun this anytime without having to go through the point and click menu.